1997. I've started working with SQL, and then back in '99 I started doing PLSQL, and I've been actually doing that ever since. I've been playing around a bit with Apex, but not too much. I became an ace in 2011. I became an ace director in 2019, and that's mostly because I talk a lot of at conferences, and lately it's a lot of virtual conferences. Um, I also build plugins for PLSQL Developer, my tool of choice. I write some stuff. I blog on my own blog. I've written a couple of articles for All Things Oracle, but they ceased to exist. But I found out the articles are at a different location. I also have written. I've actually had my own column in the OTech magazine, but that also doesn't exist anymore. So I put the articles on my own website. Um, these are my contact details. I'll send out a PDF of this presentation so everybody can download it. Like I said, I'm an Oracle Ace. I've been an Oracle Ace for almost 10 years now. If you know someone you want to nominate to become an Ace, go to the acenomination.oracle.com. It says nominate yourself, but I wouldn't recommend that. And if you want more details on the Ace program, check out the bit.ly link. As you all know, Oracle now offers the always free tier, 2 autonomous databases, data warehousing, or transaction processing, 20 gig each, 2 VMs, and lots more. Check it out. It's free forever, as long as you log in just about once a week or so. But we are experts. We can script that. So today's topic, a collection's a collection, no matter how small. This the graphics are inspired by the Horton Hears a Who movie, which is based on a book by Dr. Seuss. And one of the lines he says is, "A person's a person, no matter how small." So I thought that was a nice name for a presentation. So back in 1977, Oracle was started, and it took them about 15 years to get to Oracle 7. And before Oracle 7, it was just a SQL-based database. But in Oracle 7, they introduced PLSQL to the database. Collections were available. They were, back then, they were named PLSQL tables because they were tables inside your PLSQL, and they are always single dimensioned, unbounded, sparse collections of homogeneous elements. Homogeneous elements is saying they are all varchars, or they are all integers, or they're all, well, for even Booleans. It's no mix and match, but you can have collections of records as well. So it's pretty much like a table, but in PLSQL. In PLSQL, you have, first of all, you have, of course, the scalars. It's just one value, one number, one varchar, a Boolean. You can have a record, which contains multiple values. And then you can have a collection, which has a lot of the same values, either the same records or the same scalars. How did you do this in Oracle 7? Well, back in Oracle 7, you had to, of course, you have to create a type, and let's call it names PLSQL table. It's in this case a table of varchar 230 indexed by binary integer. That's just the syntax. That's how you do it. Excuse me. Then you create a variable based on the type, like you do a variable based on the type number or the variable based on the type varchar. This time you base a variable on the type PLSQL table. And then you start filling up the collection. Put something in position 1, and it doesn't have to be dense. It can be sparse. It can be a sparse collection. So you can put something at position 42. And if you put something on position 10, it'll keep the ordering. It'll put that in between the 1 and 42. You can even use the functions on the collections. So in this case, we'll ask the collection, how many items do you have? In this case, names count results in 3. So we add 1 more, and we'll put another one at position 4. PLSQL tables can also have negative indexes. So using -1, they are pretty much unbounded. 2 to the 31st plus 1 and 2 to the minus 31st minus 1, or the other way around. Very, very big number. And then after that, you can just loop over these items. I found myself in an Oracle 7 virtual machine, so I can show you that it actually works the way I just displayed. This is a recording of a session on an actual Oracle 7.3 instance. And that's pretty much the script I just showed you. Now, filling up these collections manually takes up a lot of your time. And since we have most of our data in the tables, we'll probably want to use the data from the table into a collection. And you can do that. Let's create 2 tables, a relation types table and netmcdot. Netmcdot is the mayor of Whoville. If you have a minute spare, just go watch the movie because it's very much fun. We'll create these 2 tables and we'll put in some data, the relation types, and in this case, some characters from the movie. And then you can create a cursor. In this case, we'll just select the first name from the netmcdot table where the type is 18. 18 is the daughters. And after we have I'll just go back a little bit. We'll have a PLSQL table based on the varchar 30 index binary integer, and then we have the names variable based on the PLSQL table, and then we'll open up the cursor. We'll fetch the names every time into the next row in the PLSQL table. And at the end, we can just close the names, and then in this case, I'll just display the contents of the collection, looping from first to last because it's a dense collection. You can also use collections as parameters in your functions, so you don't have to pass a lot of parameters or call the same program over and over again for all the items. Then there's Oracle 8. I didn't do too much with it, and I think Oracle doesn't really want to be remembered that it actually existed. In Oracle 8i, the collections, the PLSQL tables were renamed to index by tables because of the index by binary integer. And there were 2 new types of collections introduced, the nested table and the V-array. The nested tables and V-arrays can also be used in SQL, not only in PLSQL, which opens up a whole new set of possibilities. The difference between the index by tables and the nested tables and Varrays is that the nested tables and Varrays are normally always dense. They can the nested tables can become sparse if you delete items within them, but normally they are dense. You create them pretty much the same as the index by tables. Yeah, only for a nested table, you don't do an index by binary integer. So that's how you can recognize them. And then they need to be initialized. So you need to initialize your variable by using the constructor function of the type. And then you have to extend and make room for the items you want to use. You can do an extend with just one. In this case, I've extended it with 5 items right away. And then you can start filling it up pretty much the same way you did on the index by tables. And we'll just flick through this. I can fill these up using the indexes 1 to 5 in any order. It's just the order I've programmed it this time. And then after that, I can loop through the index using the first and last and display everything. A nice thing in Oracle 8i was the use of the bulk collect. Remember, we had to fetch every row and then put that into the collection, and then fetch the next row, put that into the collection, etc., etc. In this case, we can use the same cursor. We'll open up the cursor and we'll fetch bulk collect, fetch everything in one pass into the variable, and we'll close it afterwards. And then since it's always dense, we can run a for loop on it first to count, or from 1 to count, or first to last. Be aware though that all the data will be fetched into memory. And if you're fetching 100 megs of data, it'll use 100 megs of memory. Chances are you're not the only one on your system or the only one using this program. So if everybody's using up 100 megs of memory or even more, you can blow up your server's memory. Luckily, Oracle has a solution for this. There's the limit clause. In this case, I'll limit the rows retrieved by the fetch to 4, and then I'll have to open up a loop. I'll have to fetch multiple times because of there are I think 14 lines in there, and I'll have to fetch it over and over again, and I'll want to exit when my count is less than the limit I provided. In this case, I'll just fetch 4 rows, but in these small tables, you do not really need this. It's more when you're doing 1,000 or 10,000 or 100,000 rows at a time. If you want to fetch more columns from the table, you'll have to create multiple collections. In this case, we're doing the index by integer tables again, and we have a cursor where we can select 4 columns, and then after we have the 4 variables for every single column over there, and then in the cursor we'll fetch it, we'll bulk collect everything into these 4 different collections. And that's not really a big problem when you're doing 4 rows, but 4 columns. But if you're doing like 20 or 30 or even more columns, it might become a problem. Yeah, that's if you have a query with loads and loads of columns, you'll end up defining a lot and lots of scalar variables. I'll come back to this with in Oracle 9. Another nice thing of the collections in Oracle 8 was that you can create a type, a SQL type for the nested table, and then we can create a package which with functions that return this nested table type. And then in these packages, we can fill them up manually by creating a nested table, extending it by 2, and then putting in a couple of daughters in this case. Or we can have it filled up by using a cursor, using a bulk collect, of course. And then as soon as that's done, we can select column value. Column value is the name of the column that is returned by Oracle from, and then the table operator, and we have to cast the function as a nested table. This is a very trivial example, but you can do very, very nice things with this. You can use the power of PLSQL in SQL. In Oracle 9i, the index by tables were renamed again, and now they are called Associative arrays, and that's what they're called ever since. And they were used to be called index by integer, and now you can also index by varchar too. So in this case, I'm indexing by varchar to 10, and I can just put in everything records at varchar level. So I'll put in 1 at Huli, and then Hedi, which will come before that because of the alphabetic ordering. I have the 2, and Hilda will be put in between that, 3. So Oracle keeps the ordering of the elements, in this case, the alphabetical ordering. And then you'll have to use you'll have to use a while loop to go through all the indexes, because there's no way you can do a for loop on these. There's no way you can do a for from first to last with everything in between it. Remember when in Oracle 8i we had to create loads and loads of collections for all the different columns we wanted to retrieve using the cursor. Now we can create a table of a row type. In this case, I've created a table of of the table percentage row type, but you can also create an associative array table of cursor percentage row type. So, and then we'll have the cursor, which selects the 4 columns, and instead of putting everything in different collections, we'll just fetch the cursor bulk collect into the associative array based on the record types. In Oracle 9i, there was also a bit of an enhancement. We create the nested table again, varchar to 32 in this case, and then we have the functions again. But this case we make them pipelined. Pipeline means that as soon as the record is available, it gets piped out of the function, so the calling program can start working with that. And how do you do that? Well, the function still has to return the nested table type, but I'm returning actually a single row, which is just the first name type in this case. So I'm defining the row wholly and then piping that one out, and then redefining the row and then piping that one out. And at the end, I'll just have to return control. There's nothing else to return. And if we do this on a cursor, we can create a for loop, cursor for loop on select the first name based on the type you specified, and then just loop it, and every row that gets retrieved gets piped out of the function. And another good thing is you have to do less typing for it to work. You just select from table and then the function name. No casting, etc. needed anymore. In Oracle 9i, let's say we have a big table, or we create a big table. Let's call it fatmcdot, because netmcdot, but then a lot bigger. We'll put in 10,000 times the rows in the netmcdot table. And if we set the timing on and we query everything in that table, do a cursor for loop on that table and just do nothing much, it'll take you about 4.5 seconds to do that, which is pretty amazing considering the amount of work that has been done. If you take some time and create a piece of code using a limit clause, bulk collecting the table, limiting it by 10,000 rows at a time, and then doing pretty much the same as we did before, it only takes about 1.2 seconds. So that's pretty amazing. You just have to do a little bit more work. In Oracle 10G, we'll do exactly the same thing. Create the big fat table, and then if we do the cursor for loop, it now runs in 0.7 seconds. And that's probably Oracle has been updating it a bit, but the big thing is Oracle rewrites the cursor for loop into something similar to the simple loop with the limit clause. And there's it uses a limit of 10,000, I think. I'm not sure which amount it is. So you don't have to do a lot of work to speed things up. If, however, this still is not fast enough, you can still use your own simple loop with the fetch and the limit, and you'll get it down to 0.58 seconds. So yeah, it's pretty amazing what you can do, what Oracle does, and you can do even better. Yeah, but if there's a cursor for loop in there, don't even touch it, because it's probably going to be fast enough. In Oracle 10, we can also create, we can now use the, is that right? I'm just, yeah. We can now also use the nested table inside the package. We don't have to create a nested table type on the database anymore. So instead of creating the type in the SQL layer, we can just use it in the package itself, and then do the exact same stuff we did before in Oracle 9i, piping every row out and selecting everything from it. Then in Oracle 11, nothing much really happened. There were obviously some speed improvements, and I think Oracle's own usage expanded, but there was no real new syntax. What we would want to do is, I'll just try this in Oracle 11. As you saw earlier, you can create a nested table inside a package, and then use that inside the package for your cursors. But if I wanted to do something like this, create a nested table inside a package and then use it inside a query where I'll select from the table, it'll give me an error. I'll have to create a SQL-based type nested table to be able to query that in the code. In Oracle 12 though, 12c, we can select, we can create a nested table type inside a package and then use that in our query inside the PLSQL code. The good thing is we can even use an associative array, even though the associative array is not available in SQL. We can do that. We can create it in a package specification and then use that associative array inside our query, but only inside PLSQL. So that's pretty good news, because we can use the easiest way to define collections and then use the power of SQL. Remember in Oracle 7, we had to create we created a nested or an associative array. Back then it was PLSQL table, and we had to fill it up like row by row. In Oracle 18, we can now use the qualified expressions. So we will take the variable names, we'll take the names associative array constructor, and then put in all the rows at all at once. Remember though, the names.count thing, that's being evaluated at the start of the call. So count will be 0. So holy will override holy in this case. You can even make it, even more readable, I think, if you're using record types in your associative array. You can use the constructor function for the associative array, and then the constructor functions for the records themselves inside one call. And it's a lot easier to read, and probably a lot easier to understand for the next one who is opening up or supporting your code, which might be you. But after the weekend, you might not even know what you were thinking. Yeah, and then you can just loop over the collection. Then again, 19C, no really new features. I think Oracle focused on stability of the product, because after all, this is the long-term support release. Oracle 20, which is probably not gonna land anytime soon, probably gonna be 21, gives us a new set of loops using the collections. We can now go loop over the values of the collections. I haven't really played with this. This is all from the documentation. But you can loop over the values, and it's pretty much the same as we're using in the FORALL statement. You can do a FORALL statement, which is the bulk version of putting data into the database instead of getting it back from the database. And there's a for all values. Now you can do a for values of your vector. And there is a for all indices of, and you can also do a for indices of your associative array. And then there's a very tricky thing for in the pairs, and I haven't gotten my head around it yet, but yeah, it'll split the pairs into the index and the value. So, like I said, this presentation was inspired on the movie Dr. Seuss's Horton Hears Who, done by Blue Sky. If you want more information, go to these links. I've written some articles on collections and bulk processing. And you can also read some about the initialization for records and arrays, which is pretty new. Of course, you can always go to Oracle Base, find a lot of stuff on the collections, and use Live SQL, search for collections, and you'll find a whole lot of items there. These are my contact details again. And that opens it up for questions. I don't know if there's any questions. There are questions.
Thanks, Patrick. We got a couple of questions. If you want me to read them, or you're happy to read them out yourself, take your pick.
I can read them. Mike says, are the scripts from this talk available? Not yet, but I'll post them on Live SQL as soon as I got some time. I've started doing this, but it was only the Oracle 7 one done there. So they'll come available there. Mike says, again, for things like nested tables, etc., do you recommend creating types explicitly with create type, or only do it if they're needing from SQL as PLSQL? That's a tough one. As soon as you're using the nested table as a column in a table, then you'll have to create an explicit type, as you say here. If you're using it in SQL, but it gets filled up by PLSQL, yeah, just keep it in PLSQL. Don't. Lots of times you don't even have the rights to the privileges to do create type on your database. At least I don't. I don't get DBA rights. I don't get why. I hope that answers your question. If not, let me know. As a PLSQL programmer, what other tech do you recommend for me to learn. What other tech? Do you mean a different programming language? Because I don't know, because I've been doing this for the last 20 years, and I'll probably be doing this for the next 20 years. And there's lots and lots to learn on just PLSQL. In 2 weeks' time, I'll be doing a presentation on polymorphic table functions for the Australian user group. So that is a nice thing to do. But yeah, I just know in SQL and PLSQL, well, a little bit of Delphi, but I hope that answers your question. If not, let me know.
Delphi. This one.
Yeah, it's a lot like PLSQL. They've got the same root.
Okay.
Same root language.
Okay, if there's no more questions, let me grab the share off you, Patrick, for a moment.
Okay.
Thank you very much, Patrick, for giving your time, and also thank you to the attendees for giving your time to come along. Don't forget that all these sessions are recorded and they can be watched, I think, for the next 2 weeks, but I think after that they disappear. And the cool thing is, effectively, you get to watch them as long as you've registered. So you can see the URL there for the overall schedule on the screen there. So even if you have missed some sessions, go back and re-register for them, and then you'll be able to get the URL for the video, etc. So thank you very much for coming along. There's another 4 days, I think, of conference material coming along, so don't forget to check out all of that. And we will see you very soon on the next one. Thanks again, Patrick.
Thank you.